12.4 cross product part 3. If we have two vectors u and v, we can actually form a triangle with these two vectors, or you can form a whole parallelogram. Turns out the area of the triangle is 1/2 magnitude of the cross product, and the area of the parallelogram is just two triangles, congruent, and that's just the cross product magnitude without the half. Now if we have three vectors, u, v, and w, this is kind of a lame arrow there, then it turns out the volume of this parallelepiped is w dot u cross v. U cross v in magnitude in any event gives you the area of the base, that parallelogram. And then when you dot it, the cross product of u and v will actually be in this direction, perpendicular. When you dot w on this, we end up multiplying the magnitude of this vector times the cosine, and that gives us the height actually. So we end up multiplying area of the base times height, and that gives you volume. You can write this in any order. You can put w in here, u out here, v out here, whatever. And this is absolute value, not magnitude. So when we work out this triple, it's called a triple scalar product. It could come out positive or negative, just depending on which direction these vectors are going. So we take the absolute value. Here's an example. We have vectors 2, 0, 1, 0, 1, 0, 1, 1, 1. We want to find this triple scalar product to find the volume of the parallelepiped. It's arbitrary what you let equal what. I'm going to let this be u, this be v, and this be w. And I'm first of all going to calculate u cross v. And so I can transition to IJK form. Okay, no need to use a determinant. We can use a simpler form. I cross j is k, so we get 2k. And then k cross j is negative I, so we get negative I. And now we want to do w dot u cross v. Okay, and w is equal to 1, 1, 1. Dotted on, you can go back to pointy bracket notation, or you can convert that to IJK. Makes not one bit of difference. But this in pointy bracket notation is negative 1, 0, 2. Multiply it out. 1 times negative 1 is negative 1. 1 times 0 is 0. 1 times 2 is 2. And we get 1. Volume is equal to absolute value of 1, which is just 1. Here, I'll make this fancy one so you can distinguish between that and the absolute values. So the volume's 1. So if you work out a problem like this and get 0 for an answer, it means these vectors were coplanar. So for instance, you could have u and v in this plane. If w is in the same plane, obviously you get a flat figure of volume 0, and that certainly could happen in any given problem. Let's step back and look at a simpler problem involving area. Now let's suppose we have a 1, 0, 1, b of 0, 1, 0, and c of, these are points instead of vectors. So this forms a triangle. You can plot them in space. And suppose we want area of triangle ABC. Well, we can find vector AB, and we go from 1 to 0, we get negative 1. 0 to 1, we get 1. 1 to 0, negative 1. And then find AC. should start with the same point. Now we go from 1 to 1, get 0, because 0 to 1 we get 1, and 1 to 1 we get 0. And now we need to take the cross product and find half of it. AB cross AC is equal to, let's do negative I plus J minus K cross J. Again, you can use a determinant. I cross J is K, but we have a negative, so we have negative K. J cross J is 0. K cross J is negative I. Of course, we have that negative, so it's plus I. And so area is 1/2 magnitude of I minus K. Okay, it's 1/2 magnitude of this vector here, which is 1/2 square root 1 squared plus negative 1 squared. Okay, the J component contributes 0. You can put 0 squared if you really care to. And that's square root of 2, 1/2 square root of 2. This could certainly be done. It would be a two-step process if we used just simple 11th grade trigonometry. You could find the length of this side, the length of this side, the length of this side. We have to use the law of cosines to find the angle, and then you could use as a sine formula you can use to actually calculate the area in terms of this. It'd be a multi-step process. Here we were able to do it without using any trigonometry, actually. It's just pure computation. So that's all for the part 3 of the cross product.